let me solve this, the first equation or the second equation, because the two equations. Okay, let's solve the second equation. And no, second equation actually sign is -1, more difficult. Okay, I think the first one I will solve it in two methods. Okay, so let us solve this the one more example. Example 4. So example 4 by two methods. Okay, at the moment here we just the first modified one we just follow as it is, then we generated ourselves the first standard one over 9 2x cube plus 1x plus integral from 0 to 1 xt, this is 1 xt dt u of t dt. Okay, so solution, we have scheme. Now our f of x is, so here actually there is one 2x cube plus 1 plus 1x 1 over 9 2x cube plus 1x. So this function I divide into 2 plus f2 of x. But generally, look, this function I can divide into 3. One, this. Second one, this. Third one, this. By opening this into 2, we can actually divide the function into 3. f1, f2, f3. But for the time being, we just choose divide into 2. So how to get f1? f1 I choose as a first function. f2 of x, I will choose the second function. Later on, I will show you the tricks of the choosing, choosing the particular functions. Okay, at the moment, it is like this. So as we know that u0 of x, it is a f1, which is this. u1 of x equal to f2 minus 1 over 9 2x cubed plus 1x, and u2 okay, u2, so just I need these two functions. Okay, now u2 functions, it is equal to what? The integral from u2, we u2 I should calculate. u2 is, this is u1, actually, sorry, plus, sorry, I haven't finished yet. The u1 is the f2 plus lambda in our case 1, integral from 0 to 1 x of t u of t. So actually u0 u0 is e to the 3t dt, correct? So u1 u0 is like this, 3t. So now I will compute this integral. Actually, this is not x of t, this is just x times t, actually x times t times this. So it is equal to minus 1 over 9 2x cubed plus 1x plus x is out. So this one we use the integration by parts. U is a t, dv is like this. So 1 over 3 t e 3t from 0 to 1 minus integral from 0 to 1 v du. V is so t u v du. Du is dt. V is e to the power 3t dt. Am I right? When I use, so okay, let me compute. If computation is correct, then okay, plus x. So when I put t equal to 1, actually minus 0 is already 0. So I just have 1 over 3 e to the power 3 minus, so 1 over 3 e to the power 3t from 0 to 1. So now next computation is 3x. So 3x cubed, correct? Sorry. Here, F, you see, I make a little bit mistake. Look, F2, actually F0, in my case F1, F2 is minus 1 over 9, 2e cubed actually. This is, I wrote wrongly. So look, this one I wrote wrongly. You also didn't pay attention. So F2 is minus 1 over 2 e to the power cube plus 1. This is constant actually. X. You see? Okay, this one is correct. Now this is not x cube. This is e to the power cube. Okay. Now e to the power cube. E to the power cube plus 1. E to the 2 e to the power cube plus 1. 2 e to the power cube plus 1x. So plus x 1 over 9. Huh? Is this correct? 1 over 9, 1 over 9, e2, 2e cubed plus 1. So if I here calculate correctly, is this here the, when I have 1 over 9, 1 over 9, but here we have 1 over 3. There is a 1 over 9. So x out, u is t, du is dt. uv, dv, uv, v is 1 over 3 e to the 3t minus v du. V is actually 1 over 3, huh? Yeah, here I have mistake, right? 1 over 3. Because dv is like this, v is like this. So the second time, this one will be 1 over 9. So now it should eat each other, you know, it should eat each other. So 1 over 3 e cubed minus 1 over 9. So e to the power 3 minus 1. Minus 1. X is here. So when I take out the x, what happened? 2 over 9 e cubed minus 1 over 9 plus, okay, here I can give here 3 minus 1 is 2 over 9 e cubed and plus 1 over 9. Yes, now it is 0. So all cancel. The 0. If you want 0, definitely u2 is 0 because it is from 0 to 1 xt u1 of t dt. u1 of t is 0. So all the other terms now uk of x is 0 when k starting from 2, 2, 3, and so on. So if we substitute all this value into the series solution, what we have? So we have like this. So u is, we have like this. I usually write k from 1 to infinity, actually from 0 to infinity. So uk of x is u0. u0 we have e to the power 3x plus u1. u1 is already 0, u2 is 0, so it is e to the 3x. You see, actually the modified one is mostly focused at 2 steps. This one, another name is a 2 steps method. So they play with the function, the right side function, such a way that when we choose the u0 fx and the rest of part as a u1, so that this u1 should be equal to 0. To do that, so now I'm telling you the techniques, or what we call it, the subtle points of the choice of the functions. So actually, when you calculate the second integral by putting the u0, whatever that integral, the value we have, you will choose as negative this function, negative. But sometimes whenever you choose the f2 and f1, or it is better say f0 and f1, so f1 is chosen by the opposite side of the second integral. So when we add up, we should get f function. If we cannot get, even u1 is 0, but we cannot get f function, then we have the iteration solution. I mean the approximate solution. We cannot get exact solution, but in that case we have to calculate up to the n terms and sum it, then get the approximate solution. Okay. Now the same problem, you see, in 2 steps I got the exact solution, e to the 3x. So this is our solution. Now if I use usual procedure, the standard, now I will apply standard ADM. In the standard ADM, u0 is chosen as f of x. F of x is minus 3x minus 1 over 9 to c, not c, e cube plus 1. Actually, my x is outside. So now what about u1? u1 is equal to integral lambda is 1, 0 to 1, xt u0. u0 of t, e to the 3t minus, okay, I will say 2 over 9 e cube, okay, e cube plus 1 over 9. This one I can say, okay, so it is better to say, because this is a constant actually. This one constant. So constant, better leave it as it is, 1 over 9 2e cube plus 1 t, then dt. So I have to compute. So first one, integral from 0 to 1, t e 3t dt. Second constant, I factor out 2e cube plus 1. Then integral from 0 to 1. So x x I put here. So t square dt. So the first integral already we have seen. So first integral actually beta t e to the 3t dt. So u and t uv 1 over 3 u is t e to the 3t minus integral from 0 1 actually 1 over 3 e to the 3t dt. So in other words, so this one I just put the value for the second one, 1 over 3. You see, e to the 3t, e to the 3 minus 1, e to the 3 minus 1. Just I put the value 1 over 3. So it is, so e to the 3t, 1 over 3. E to the power 1 minus 1. Actually, the second one is 1 over, can I say 1 over 9? Minus 1 over 9. So 1 over 9 e to the cube minus 1. Huh? Can I say like this? I think it is correct, right? I just put, please check because I didn't calculate on the paper actually. Because this is it is not there. I just want to show you the differences and the simplicity of the second one. So x, now I will put that value 1 over 3. Please, any mistake, because here small mistake gives very big changes and not correct answer. E to the power cube minus 1. So this is the first integral, minus x over 9 and 2e cube plus 1. So this is t cube means 1 over 3. So you can see now, this is the second iteration. Now what about third iteration? I just simplify this second iteration. Actually, go to x here from 0 1. When I put the 0 1, 0 is 0. When I put 1, this is 1 over 3. 1 over 3 e to the power 3. So e to the power 3 minus, am I right? Because this is should be value, the real value, minus x over 9, and this is 1 over 3. So this one 2 values, this one 1 values. So if I take out x, what I have 1 over 3 e cube minus 1 over 9 e cube plus 1 over 9 minus 2 over 9 e cube and 27. You see here 27, because here we have 3. 27 e cube minus x, x is outside, 1 over 27. So you see, we don't have cancellation. We can simplify only. You see, actually, if you properly calculate, yes, we have some simplifications, but still the u1 is not equal to 0. So we have to calculate u2, u3, then get the summation up to the end. Then when we summing, of course, u0 plus u1 and u2 and so on, we should have this series, but cancellation series. At the end, we will get only the first function. So generally, this one now, it is long calculation actually. Maybe next time I will show you. But using standard method, we can get the solution, but with the long way. And sometimes we have the if no cancellation terms appear, then we have to stop at point N, and that one is a approximate solution. For this case, we should have. Now, I'm just going to stop at this point because you can see the very long term and next term will be much more difficult. And I hope that there is some mistake here. So you see, the modified one is very simple. Mostly it focuses on the two steps. U0, we choose such a way that U1 should be 0. The next iteration should be 0. Okay, so actually this dividing function into 2, we should divide into 2 such a way that the F2 functions plus this function should be equal to 0. That is a subtle point and the very critical point. If we are able to do that, and by adding these two functions, get the f of x functions, then it is okay. In other words, if you pay attention, actually this f of x right side function should contain the solution actually. You see, this e3x is a solution of without this part, you know, without this part, actually it is a solution of this equation. So if f of x contains the solution, then we can choose f0 and f1. Okay. If not, whatever you do, next u1 may not be 0. If it is not 0, then u2 will not be 0. You see, mostly this f1 is a critical choice. You see, if I choose this one use f0 and this one f2, then f2 plus this integral never 0. So u2 is not 0, u3 is not 0. So then I have to calculate up to the n. Okay, I think that is the for today technique. And after this, they show one more example. And as 2 more examples, hey, 3 examples. Then they actually give the one applied problems, noise term phenomena. Today I'm not going to teach because this one little bit need to explain in the critical way and not easy to get the solution. Actually, solution is simple, but there is a subtle point. Okay, we need to talk about. So after this, they have given very good exam exercises. So please, my students, all the PhD and master students, please solve enough. So next time, I will solve one example again. Then we go to the variational iteration method. Okay, maybe next week is also we try to solve more examples by 2 methods, modified one and standard one. Okay, so I think now it is already 10:30. Actually, from 9:30, 10:30, 1 hour we plan it, and I hope it is clear picture and nothing difficult so far, and hope you can finish the rest of the problems. Okay, any questions?
Sorry for interrupting you.
No
In a
problem.
previous example, I think that he was answer cosinus x, not cosine x to x. Can you Show me, please. First example.
Okay.
In your
First
in your
example,
note.
okay,
In your
good.
note.
You mean here?
Yes.
Okay. In that case, let me show you my solution. Very good. MashaAllah. So, you meant the first example, right? No, not this example.
Yes.
Okay.
Maybe I'm wrong. Not. I want to check it. Sorry.
Okay. No problem. Good. So, even this one, this example.
Yes.
So, standard ADM. So you see, in the standard ADM, here we can get exact solution because you see cancellation terms appearing every time. For U1, we have this. For U2, we have 2 over 3, the second term,
Yes.
2 over 3 pi cube, the new term. This new term will be cancelled next term.
Yeah, it's
actually
so clear, teacher.
Okay, here what is your question?
The answer is cosinus x, I think that, not cosinus 2x.
Oh, okay. Sorry. In that case, I have, yeah, cosinus x actually, not 2x. Why I write? Thank you very much. This is not cosinus 2x. This is x. Oops. Cosinus x actually. Thank you. Yeah. Right. Let me write with this one. Here something wrong. Like, you know. Anyway, so this one should be okay. If I remove, then write cos x. Cos x. Here cos x, not cos 2x, cos x, right? Plus 2x cancel with 2x and so on. So at the end we get without this cosine x. Yes, thank you. So that is a solution. So now to learn this method well, you have to solve many examples. Then you will be master. Okay, please do it. Next week we will repeat again and compare with the two methods. And sometimes by wrongly choosing of F0 and F1 gives more difficult than the S1 function, you know. So if you choose wrongly, so you will get wrong or more difficult, not wrong, actually more calculations, and it leads to heady problems. But at the end, you can get the solution, yes. You see, in the numerical, you have to be very, very accurate and very careful and check the every process. Then you can get the solution. Okay, so that is good. But it is anyway, this is a very good and strong method. This is for linear case, very simple. For the nonlinear case, how we apply, that's important. Later on, I will teach you how to solve the nonlinear problem using ADM. And then we will compare with the variational iteration method. So you will learn another 2 more methods, variational method and the ADM method, addition decomposition. Okay, so I will stop at this point. So today, alhamdulillah, many students attended.
Numerical bo'ldi.
Yeah, mashallah, sizga katta rahmat.
Rahmat hammalaringizga.
Zoomda nima qilib ko'pchilik qatnashishga imkon bo'ldi.
35 taga yetdi. Haligi ayrimlari interneti ustuvchi bo'lmagani uchun kirib chiqib